Good evening, welcome. My name is Andrew Copson. I'm the Chief Executive of the British Humanist Association, and I'd like to welcome you to our annual Voltaire Lecture this evening. The Voltaire's Lecture Fund was established by the legacy of Theodore Besterman, biographer of Voltaire, for lectures on any aspect of scientific or philosophical thought or human activity as affected by or with particular reference to humanism. The BHA now oversees the fund. Previous Voltaire lecturers have included Herman Bondi, Barbara Wootton, Bernard Crick, Richard Dawkins, Anthony Flew, Michael Foote, Robert Hind, Ludovic Kennedy, Simon Blackburn, Natalie Haynes, Robin Ince, Keenan Malik, Ray Tallis, and Dick Taverne. The last president of the BHA to give the Voltaire lecture was the philosopher A.J. Ayer. Usually, the BHA president chairs the lecture, so we've had to draft back in our only living ex-president, for the evening, Polly Toynbee.
Andrew, you make it sound ominously like a death sentence. But I'm still alive. Here I am. And I'm absolutely delighted to introduce this lecture. I'm so looking forward to hearing it. It's called Learning from the Past, Science and Rationalism in Medieval Islam. I'll tell you a little bit about Jim Al-Khalili, who became president last year. Iraqi-born, theoretical physicist, author and broadcaster, professor at University of Surrey, where he teaches and carries out research in quantum physics. Currently, he presents, as I'm sure you've all heard, often the Life Scientific on Radio 4. On Tuesday mornings, it says here, but I hear it in the evening, when it comes on again, where he interviews prominent scientists about their life and work. And he's presented a whole lot of scientific documentaries on television, particularly on BBC 4, where he says he's happiest as he can really get his teeth into a subject. Here are some quotes from him, which I really like. I'm against creationism being taught in schools because there is empirical evidence that it is a silly notion. We're all with him. I'm passionately concerned about the rise in pseudoscience, in beliefs in alternative medicine, in creationism, the idea that somehow it's based on logic, on rational arguments, but it's not. It doesn't stand up to empirical evidence. There are several other wonderful quotes here, but I think it's much better that we get on and actually hear from the man himself, from his own voice. I'd like to just add that he's author of a great many books, two of which are here of the many books, his two most recent ones, Pathfinders, The Golden Age of Arabic Science, and Paradox, The 9 Greatest Enigmas in Science. So now I give you Jim Al-Khalili.
Thank you very much, Polly. Good evening, everyone. Well, it's a real pleasure, and I gather now a real honor to be giving the Voltaire Lecture as president. Last year, Steven Pinker, the American author and psychologist, gave the Voltaire Lecture, and I had the pleasure of introducing him. And that was one of the first duties I had as president, and still not quite sure what was the job involved. I'm thoroughly enjoying it. I'm now sort of halfway through my presidency. So I'm not going to be talking about humanism as such. Essentially, a lot of the stories I'm going to tell in this lecture are based on material that I had written about, and indeed I made a BBC documentary called Science and Islam. What I'm not going to be doing is bashing Islam and saying how backward it is and how anti-scientific it is, nor am I going to view it through some rose-tinted spectacles and say how wonderful and enlightened it is compared with other religions. I'm a scientist, and I'm going to be telling the story of a forgotten period in the history of science, and how that was a period of rationalism and openness to inquiry and to question, and how, to a large extent, that's missing from vast swathes of, certainly of the Islamic world, but certainly more wider, even in the Western world today. So what lessons can we learn from that enlightened period during medieval times? Let me start by asking a question. When we think about modern science and the way we do science and how science is distinguished and separated from pseudoscience and superstition and other beliefs that are not based on evidence and experimentation, with the scientific method, that you come up with a hypothesis that you then test. And if your experiment suggests that that hypothesis, that theory is wrong, then you have to be prepared to throw it away and come up with something better. Usually, historians of science will say, well, it began with the scientific revolution, going back to the 16th century, people like Copernicus, the man who he wasn't the first to come up with the heliocentric model, the fact that he said the Earth goes around the sun, not the other way around. There were others before him, but he's the one who really kicked off the scientific revolution in Europe. But really, probably the early 17th century, people like Galileo, in his book Il Saggiatore, or Francis Bacon, René Descartes. These are people that historians would say first defined what the scientific method is, what modern science is all about. I'll read you a few quotes. By far the greatest hindrance and aberration of the human understanding proceeds from the dullness, incompetency, and deception of the senses, in that things which strike the sense outweigh things which do not immediately strike it, though they may be more important. Hence it is that speculation commonly ceases where sight ceases, insomuch that of things invisible there is little or no observation. Unless you can see it with your own eyes, that's it. But they were starting to do science at that time where they were looking for evidence other than what your senses told you, common sense would tell you. As another one, it cannot be that axioms established by argumentation should avail for the discovery of new works, since the subtlety of nature is greater many times over than the subtlety of argument. But axioms duly and orderly formed from particulars easily discover the way to new particulars, and thus render sciences active. Those two quotes were from Sir Francis Bacon. And he is one of the people, when you say, how did modern scientific method, where did it have its foundations? We normally say Sir Francis Bacon. Here's another one. We should distinguish the properties of particulars and gather by induction what pertains to the eye to be uniform, unchanging, manifest, and not subject to doubt. After which, we should ascend in our inquiry and reasoning, gradually and orderly, criticizing premises and exercising caution in regard to conclusions. Our aim in all that we make subject to inspection and review being to employ justice, not to follow prejudice, and take care in all that we judge and criticize that we seek the truth and not be swayed by opinion. Was it Francis Bacon? Was it Descartes? No, that was Al-Hasan ibn al-Haytham, Latinized name Al-Hazin. He spanned the 10th and 11th centuries. He was an Arab physicist born in Basra, southern Iraq. And that is a quote from his famous Book of Optics that was written round about exactly 1,000 years ago. We're not quite sure exactly when, but between 1010 and 1020, he was in Cairo. He was under house arrest. I'll say something about that later on, how he came to be under house arrest. But that is the scientific method, 600 years earlier than René Descartes and Francis Bacon. And that is how we do science today. This was at a time when Europe, well, Western Europe, was deep in the Dark Ages. And it's very often that we imagine that because Western Europe was stuck in the Dark Ages, that everyone else was as well. But of course, that was a time when China and India and the new Islamic empire were thriving and, in comparison, very enlightened. Here's another quote. Because reason is the only thing that makes us men and distinguishes us from the beasts, I would prefer to believe that it exists in its entirety in each of us. That was René Descartes. Here's another one. The stubborn critic would say, what is the benefit of these sciences? He does not know the virtue that distinguishes mankind from all the animals. It is knowledge, in general, which is pursued solely by man, and which is pursued for the sake of knowledge itself, because its acquisition is truly delightful, and is unlike the pleasures desirable from other pursuits. Maybe he didn't get much. But for the good cannot be brought forth, and evil cannot be avoided, except by knowledge. What benefit then is more vivid? What use is more abundant? That's absolutely beautiful. That was due to a Persian polymath, Al-Biruni, also a contemporary of Ibn al-Haytham. That's how we do science, and not just how we do science, but why we want to ask questions about the world around us, not because we're told to by some higher power, or because there is some beneficial application, although that's a perfectly good reason to understand more about our world, but just because we're curious about how things work. Again, this is someone 1,000 years ago in the Islamic world. So I want to tell you a little bit more about the medieval Islamic empire and the world that some of these scholars lived in, and why they were able to be so enlightened, and what went wrong, essentially. It's quite recent that we had forgotten about this golden age of science. This is the frontispiece from a book by an astronomer, Hevelius, who was one of the first people, a few decades after Galileo, to point the telescope up at the moon and study the surface of the moon. And he wrote this book about the moon in the mid-17th century. And on the front cover, he has these two men. They look rather similar, I guess, in their robes and their lovely headgear and their beards. The theoretician and experimentalist. The chap on the right is Galileo with his telescope. And the one on the left is Ibn al-Haytham with his mathematics and his algebra, his geometry, his paper. So during the Renaissance and the scientific revolution in Europe in the mid-17th century, they were well aware of the contribution of some of these medieval scholars. What's sad is that today, not only in the West are many of these people unknown. We might have heard of, the Avicennas and Averroes as some, philosophers that had something interesting and intelligent to say. But many others, it's not just in the West that they're not known, but even in the Islamic world itself, they've been forgotten. Or certainly their accomplishments in science have been forgotten, even if their names are household names. This is the last quote before I get stuck into my story. Common sense and the principles of logic and reason are our only reasonable choice for governance and progress. Being scientists, we understand this easily. The task is to persuade those who do not. That's from Pervez Hoodvoy, who's a Pakistani physicist, and he wrote that a few years ago, and he was lamenting the fact that the Islamic world is disengaged from science. He said, well over 1 billion Muslims and extensive material resources. Why is the Islamic world disengaged from science and the process of creating new knowledge? I'll come back and revisit that at the end. Let me say something. So this is the front cover of my book, Pathfinders. Pathfinders was a title that we only settled upon at the last minute when I was finished writing this book. It was going to be called The House of Wisdom, after that almost mythical academy in Baghdad, where the scholars gathered during the Abbasid dynasty in the 9th century. And then my publishers discovered that there was another book with the same title, The House of Wisdom, written by an American author on the same subject. And they were quite bullish to begin with. They thought, well, they said, no, let him worry about the fact there's another book with the same title. Yours will do better. And at the last minute, they got cold feet, and they said, maybe we can think of another title. So we came up with Pathfinders, and I was aware that it was associated with another Arab scholar from the Middle Ages called Ibn Khaldun, who lived in North Africa, who is regarded now as one of the founders of social science, one of the founders of economics. And the quote was, "He who finds a new path is a pathfinder, even if the trail has to be found again by others. And he who walks far ahead of his contemporaries is a leader, even though centuries pass before he's recognized as such." And it seems to be quite a nice encapsulating description of some of these scholars that we've forgotten about. And I thought it was Ibn Khaldun's quote, and then we discovered afterwards that it was actually a quote about Ibn Khaldun by his biographer, a chap called Nathaniel Schmidt. But fine, it seemed to be a nice title, and we were happy with it. But just as a coda to the story, when the book came out in America, it was called The House of Wisdom. So Penguin US weren't quite as nervous as Penguin UK. That's fine. Okay, what is my interest in this subject? Well, as Polly mentioned, I was born in Iraq. My father's from Iraq, my mother's English. They met. She was a librarian in England. He was over studying engineering. Met, married, went back to Iraq, and I was born there. Although English was our first language spoken at home, I did my schooling in Iraq, certainly until the age of 16, and when we decided to jump ship when Saddam came to power. It's one thing to live under a dictatorship. It's another to live under a genocidal maniac. So we thought we'd get out when we could. So I was born in a district of Baghdad called Qaradat Maryam, which is just on the other side of the Tigris River from what is the US-controlled green zone today. And it was only a few miles upriver, north of the hospital where I was born, that a great caliph was born many hundreds of years earlier. I'm not trying to make a comparison between the two of us, just other than, we were born in the same, well, maybe if you want to make that comparison, that'd be fine by me. His name was Al-Ma'mun, and he would become the most important character in kick-starting this golden age of scholarship and science. He was part of the Abbasid dynasty. The Abbasid dynasty came to power in the mid-8th century, and the Islamic Empire was only just over a century old then, and the capital of the empire then was Damascus, now the capital of Syria. The Abbasids were very influenced by Persian culture, and they really wanted to build a capital that was closer to what was then part of the Persian Empire, which had come under Islamic rule. So they created their new capital, Baghdad, in 762. And the round city was a fortified small city with the caliph's castle and the mosque and all the accommodation. And then outside of that were the army barracks, and then all the market towns, and the poorer people would live. So the city grew very, very quickly. But the round city itself is the original Baghdad. And there's no archaeological evidence of it anymore. We're not even sure exactly where it is, but historians, so this is a map by a historian, but if you superimpose the round city on modern-day Baghdad, you can see it's smaller than the green zone. So all the swimming pools they have in there, I guess, that take up so much space. So this is modern-day Baghdad. For the last few years of my life, we lived around about there, in case you're interested. And there's the airport. Baghdad was, by the beginning of the 9th century, Baghdad was the largest city in the world. Historians, although they can't always agree on this, many would argue that Baghdad was the first city to have a population of over 1 million. It was certainly much bigger than the other big cities of the old world, Constantinople, Athens, Rome, Damascus. But of course, it's unreliable. I mean, how do you work out there was no reliable census to work out the number of people who lived there. One historian tried to work out the population by calculating the number of bathhouses, public bathhouses there were, and then working out the average number of people who would use a bathhouse and multiply it. So he got to something like 20 or 30 million. So clearly not very good at maths, but Baghdad was flourishing at this time. The most famous caliph, depicted here in a 19th century painting, was Harun al-Rashid. Harun al-Rashid is one of the regular characters in the 1001 Nights. He's the caliph who walks around the streets of Baghdad with his vizier, Jafar, and so he's a very colorful character, but he was also the caliph, the ruler of this vast Islamic empire at the time of its greatest extent, and certainly when Baghdad was at its most opulent. This painting shows him receiving as a visit from King Charlemagne, who was his contemporary, the powerhouse in Europe. And it's said, a lot of historians wrote about this, that King Charlemagne was in awe of the splendor of Baghdad. There was nothing in Europe to rival it at that time. But it was Harun al-Rashid's son, Al-Ma'mun, who really got this golden age going, and he created this house of wisdom. Again, historians, as a scientist, I can be a bit sort of loose about it. I don't have the hang-ups that the historians have. about what the lack of evidence for exactly what the House of Wisdom was and where it was. Some would say it was just a library, others say it was no more than a translation house, others would say there were many such houses of wisdom in Baghdad, others would say they were there around before al-Ma'mun's time. But the fact is, it has a very powerful symbolic meaning. And Baghdad, certainly at this time, and we're talking about the early 800s AD, Baghdad was the place to go to if you were a scholar. Not just if you were a scientist, if you were a poet or a theologian or a musician. It was the place to be. It was the center of happening things. Al-Ma'mun is said to have dreamt that Aristotle came to visit him and told him that he had to seek knowledge and get hold of books, because that was the most important thing, and then spread that knowledge among his people. Al-Ma'mun was part of a culture and a society at that time that were obsessed with learning, very much influenced by Persians. One Persian scholar at the time said, "We Persians have all the ideas, but you Arabs have the words," because everything was written in Arabic, because it was the language of the Quran. So therefore, it was the official language of the empire. And so what Al-Ma'mun did was, really, he and across the whole swathes of high society of the Abbasid dynasty, they would provide patronage to get people to translate books from other languages into Arabic. So this is the Islamic empire. So this is at the start of it when it was still in Arabia, and then by the sort of mid-7th century it spreads. By the mid-8th century it has an area which is larger than the Roman Empire at its greatest extent. And wherever they would go, would try to expand their borders, they would gather books and bring them back to Baghdad. And there began a 2-century-long translation movement, mostly from Greek. There were Jewish and Christian scholars in monasteries who were studying the works of the classic works of the Greeks. So Ptolemy's book on astronomy, that became known as Almagest, Euclid's Elements, the philosophy of Plato and Aristotle. So a lot of these books were either in their original Greek, or they'd been translated into one of the languages of the region, Syriac, for instance. Thanks to Alexander the Great, a lot of the Greek knowledge had spread. There was a two-way process, exchange of knowledge as far as India. And so a lot of these texts that were being brought back to Baghdad were also in Pahlavi and Sanskrit. And they were translating them all into Arabic. That's what kickstarted the translation movement. In fact, there was a second translation movement that sort of began around about 1000 AD that took Arabic texts back to Europe. So European scholars, there were names like Robert of Chester and Gerard of Cremona, who would come to cities like Baghdad, and they go to Spain, Andalusia, like cities like Cordoba and Granada and Toledo, and they would learn Arabic, and they would translate these texts back into Latin. And some of those texts were the original Greeks, the works of like Aristotle and Plato and the physician Galen, people like that. But there were others that were the original books written by Arab scholars. You see that one of the mistakes that people have made is assume that this Islamic empire, these Arab and Persian scholars, were simply looking after European knowledge while Europe was in its dark ages. And then when Europe reawoke with the Renaissance, they said, there you go, we've kept them safe for you. And Europe reawoke to reclaim its heritage. But of course, that's not how science works. Science doesn't belong to one particular civilization or culture or language. Science is a baton that's handed from one civilization to the next. Sometimes things are repeated. Sometimes discoveries are remade because you're unaware of someone earlier. But on the whole, it progresses incrementally, step by step. So a lot of those texts that were translated from Greek and other languages into Arabic were then translated several times, improved upon, and pretty soon the scholars in cities like Baghdad were making their own original contributions to science. I quite like putting sort of top 10 lists, typical autistic scientist, who are the greatest scientists. I once gave a talk to my students. It's a football match between two teams, the Islamic scholars versus the Greek scholars. So I had Socrates and Plato bossing the midfield for the Greeks, and I had Biruni up front. Anyway, so the one thing I should say, of course, is that, and this is the subtitle of my book, The Golden Age of Arabic Science. That's an important and carefully chosen phrase. I don't call it the Golden Age of Islamic Science. That'll be wrong. After all, if you think of other terminology, things like Jewish science, well, that was used as a derogatory term by the Nazis to undermine the work of people like Einstein in the 1930s. Or Christian science, which means something very different indeed. So it's sort of dangerous to refer to the science of a particular civilization or period by the religion of those who practice it. In any case, many of the scholars of this period were not Muslims. There were Christians, there were Jews, there were Zoroastrians, there were Sabians, there were all sorts of people with different faiths. So, not Islamic science, but also not Arab science, because actually the majority of those scholars, certainly if you look at the ones who had the most influence, whose work is now remembered, there's probably more Persian than Arab scholars. Arabic science refers to the language of the books. They all wrote in Arabic. And at that time, if you wanted to get your book read, wanted to have some influence, you had to write in Arabic. It was the international language of science for something like 600 years before Latin took over. So, Jabir ibn Hayyan, he was one of the earliest scholars of this period. He worked in the city of Kufa, south of Baghdad, early 9th century. He was also referred to as Jabir the alchemist. Today we know the distinction between chemistry and alchemy. Chemistry is a proper science. Alchemy is based on superstition and magic and mystery, the philosopher's stone and so on. But of course, back in medieval times, there was no distinction between chemistry and alchemy. So, people were doing alchemy. There was lots of nonsense, but in amongst that was some serious, careful experimentation. So even the Arabic word for chemistry, by the way, is alchemia. And even today, it's called alchemia. So that's where the word alchemy comes from, and chemia, without the definite article al, chemia becomes chemistry. It comes originally from the Greek. And so there was no distinction between chemistry and alchemy. But Jabir ibn Hayyan, so a lot of the techniques he talked about and synthesizing acids and alkali and alcohol, those are both Arabic words. That would be boring if I just listed all the words that have Arabic origin. But he was very obscure in his writing, to the extent that the word gibberish derives from the Latinized version of gibber. Gibberish means writing like gibber, right? Because I don't understand what you're talking about. It's quite an interesting connection. But he was probably the first of these scholars to actually also do proper science. Chemistry was one of the early sciences that were developed there. They went on to develop things. There was a very sort of thriving soap industry when Europe was all still rather grubby. But also, colored stained glass and coloring for tiles and ceramics and so on. Hunayn ibn Ishaq was a Christian translator. He was also a great mathematician. He also translated a lot of the medical texts of Galen, the Greek physician. Al-Kindi was the greatest Arab philosopher. Many of the philosophers were Persian, but Al-Kindi was the first person really to synthesize, or try to synthesize, Aristotelian philosophy with Islamic theology, somehow to sort of bring them together. It was something that other philosophers after him were criticized for because it was seen as un-Islamic. So Avicenna, Ibn Sina, was the pinnacle of philosophy in the Islamic Empire, was thanks to Avicenna. Again, a synthesis of theology and philosophy. And a lot of other European scholars, so Maimonides, the Jewish scholar, read Avicenna, was influenced by him. Thomas Aquinas also read Avicenna, was influenced by him. So the idea of merging Greek philosophy with theology. But Al-Kindi was the first person, the first true philosopher of this period. Al-Khwarizmi was a mathematician, and I'll say something about him in a moment. Rhazes, as he's known in Latin, was a physician. He built the first hospitals, as we would understand them today, as a place where many sick people would go and be looked after and treated by several physicians who would dish out medicines, remedies. There'd be an apothecary nearby and so on. So Al-Razi built these first hospitals first in the city of Ray, which is now a suburb of Tehran, and later in Baghdad. Okay, Al-Khwarizmi was a Persian mathematician. This is his book, as you can see. You can read Kitab al-Khwarizmi, as it says. I have the advantage over you that I can read Arabic. And what's nice is that Arabic hasn't changed since the early time, because it's the language of the Quran. In English, if you struggle to understand Chaucer, which is only a few hundred years ago, but over 1,000 years ago, when I was writing my book, I could go to the original text in the British Library and think, oh, I can understand that. The punctuation might be a bit silly and the language strange, but you can follow it. Well, this is a book on mathematics. Al-Khwarizmi is regarded as the father of algebra. The book's name is Kitab al-Jabr, the book of completion. And that word, al-Jabr, the completion, is what we use today for the field of algebra. It was the first book on algebra. There were other mathematicians who were sort of doing algebra. There was a Greek by the name of Diophantus. Even Babylonians, there's cuneiform writing where they're solving quadratic equations involving x squared and triangles and so on. But Al-Khwarizmi was the first person to generalize it into a method, a technique for solving all sorts of equations. Until then, it was basically what's called number theory. This was the first true book on algebra. What he did was provide the recipe for solving an equation. So, the x, the unknown in an equation, he called it the thing, al-shay. And he said, the shay multiplied by itself and add 3 times the shay equals 10. How would you work out what the value of al-shay is? You do the algebra to work out x equals such and such. He went through that recipe, that series of steps that we would now refer to as an algorithm. Well, guess where the word algorithm comes from? The Latinized version of Al-Khwarizmi's name, algorithmus. So his name gives us algorithm and his book gives us algebra. But what's really fascinating about this book, and here's a textbook on mathematics that's written entirely in prose. Not a single equation in the whole book. It does mean it takes him half a page to solve something that you could do in 2 or 3 lines that you learn at school. But actually, that's a detail. Symbolic algebra is just a way of doing it more quickly and efficiently, rather than a new technique. It was also a book which was very useful for wider Abbasid society. It became very, very popular. It was used to solve problems like division of land and agriculture, working out taxes, working out inheritance in economics. And a lot of people made use of it. A lot of mathematicians were influenced by it. The European mathematician Fibonacci, the famous Fibonacci series, he came to Baghdad, he learned Arabic, he translated Khwarizmi's book and took it back to Europe. It was extended further by other mathematicians. One of the greatest mathematicians of medieval times was Omar Khayyam. Not a bad poet, but actually a better mathematician in my view. Oh, controversial. But you sort of don't hear much about that. You don't hear that Omar Khayyam was this wonderful mathematician. So this was one of the great texts, one of the most important books in mathematics by Al-Khwarizmi. The Greeks, they didn't really do algebra. Greeks did geometry. That's what they were good at. They were the masters. And the standard book, Greek book on geometry, was by Euclid. It's called The Elements. And basically, Euclidean geometry is what everyone still learns at school today, everywhere in the world. All the stuff about triangles inside circles and parallel lines and so on. That's all Euclidean geometry. And that was one of the books that was translated very early on into Arabic because they knew that was one of the most important texts. So the books that were translated, so there was Aristotle's work, there was Euclid's Elements, there was Galen's medical texts, and of course there was Ptolemy's book on astronomy, Almagest. Now, in terms of physics, that's my subject. If I think about who was the greatest, who we would now refer to as a physicist in antiquity, and I guess it would have to be Archimedes. Then 2,000 years later, we have Isaac Newton, the greatest, probably the greatest scientist who ever lived. And I'd like to ask, who is the greatest physicist in that span of 2,000 years between Archimedes and Newton? And I would say it's Ibn al-Haytham, the chap who I quoted to you at the start as being one of the founders of the scientific method itself many years before the Europeans hit upon it. Now, Ibn al-Haytham's a very colourful character. We know a lot about his life. A lot was written about him. I'll just share with you one or two stories. He was born in the late 10th century in Basra in southern Iraq. He had this very boring administrative job, which he didn't enjoy, and he really wanted to be out there doing science and trying to understand, for instance, Ptolemy's book on astronomy. Everyone who wanted to understand science, that was the book you had to study. But he couldn't get out of this job. I think his parents, he got the job, some sort of form of nepotism. His parents had secured it for him. He didn't enjoy it. So to get out of work, he feigned madness. He just, I'm mad, me, and he got the sack and allowed him the freedom to go off and pursue learning and science. He learnt that there was a new dynasty in Egypt, the Fatimid Empire, and they had just founded their new city, their new capital, Cairo. He understood that the caliph there was rather concerned about how they could control the water, the floods of the Nile. And so he wrote to the caliph and said, I've got an idea. It's an engineering project. You'd have to build some sort of a dam across the Nile, right about where today's modern-day Aswan is, in fact. He said, and I can come and do it for you. So he gets called over to Egypt. It's not clear whether the caliph comes down with him to southern Egypt or whether he goes by himself. But anyway, he gets there and realizes that as an engineering project, he's really bitten off more than he can chew. There's no way he can do it. And of course, he's rather then worried about how he's going to, save face. Bear in mind, the caliph is also known, the nickname of the caliph is the Mad Caliph. And not mad in a nice cuddly way like Ibn al-Haytham. No, nasty mad. So he says, well, how do I get out of this one? So I know, it's worked once before. He feigns madness. And the caliph, sort of feels sorry for him. And only puts him under house arrest, but at least he doesn't chop his head off. So Ibn al-Haytham spends the next 10 years or so until the caliph dies. So this is the turn of the 11th century, and around about exactly 1,000 years ago, he's under house arrest. It's not clear, it was in Cairo. It's not clear whether it was part of the Al-Azhar mosque there or somewhere nearby. But that's when he carries out his most important work, and he writes, for example, the Book of Optics. A very, very influential book. It was completed 1,000 years ago. One of the lovely things in this book is that he's the first person to really explain how vision works. The Greeks couldn't understand, they couldn't agree on how we see things. So there were people like Plato and Euclid who were into their geometry, who would draw things like ray diagrams. When you learn at school about light going through lenses and refracting and reflecting and do these lines and arrows and they cross over at focal points. They were doing that sort of thing. But they thought the way we see is by shining light from our eyes onto the object. It's called the extra emission theory. Because they said, how else can you pick out a detail, the needle in a haystack? How can you see a detail when if everything's throwing light at your eyes, how can you discriminate? On the other hand, there were people like Aristotle who believed in the intra-emission theory, that light enters your eyes, but not using light traveling in straight lines and ray diagrams and incidence and reflection and so on, but just sort of a general, vague, fluffy Aristotelian lightness enters your eyes in the way Aristotle did. Aristotle wasn't the best mathematician, but pretty smart, I should add. So let's not do him down. Ibn al-Haytham says, I believe light enters our eyes from objects, but I'm going to use the ray diagrams, the geometry of people like Euclid. So he mathematizes optics in the right way, and he talks about angles of incidence and reflection, he talks about refraction, and he does experiments with lenses. He uses a camera obscura, a pinhole camera, which had been developed in China much earlier, but he uses it to carry out experiments to show that light travels in a straight line. He documents what he does. He basically, apparatus, method, results, that's his experiment, and he uses experimentation to prove his hypothesis about the nature of light. He then writes down the mathematics or the angles and tabulates them about the properties of how light moves and how it behaves. That's science, that's modern science. And he says, basically he makes very careful, and he even refers to others, encouraging others to repeat his experiments to make sure that they agree with him. His book was translated into Latin in the early 13th century, De Aspectibus, which influenced many European thinkers. People early on, people like Roger Bacon, but also during the Renaissance, actually influenced a number of artists in Florence, because one of the things that he writes about in his book of optics is the notion of perspective. In fact, his work then became part of a later study called De Perspectiva, where the notion that distant things are small, and lines going to infinity in the distance, further away they are. And artists found that very important. And they were studying the Latin translation of Ibn al-Haytham's book to make sense of their art. One of the things that... how are your maths and geometry and trigonometry? I don't know whether... Shall I? Yeah, good, thank you. Right. Well, no, because this is fun. We learn at school that Snell's law of... Who remembers Snell's law of refraction? Okay, about 10% of you, good. Anyway, refraction, that the idea that a spoon in a glass of water looks bent, or that the bottom of a swimming pool, before you're going to dive in, looks a lot shallower and a lot closer to the surface than it really is. That's because light changes direction when it travels from one medium to another, air into water. And the angle, the change of angle that it makes is encompassed in this, what's called the law of refraction. The ancient Greeks thought that the ratio of angles, so this is called the angle of incidence between the line that the beam takes and the vertical. So this is this is the surface of water. There's water here, there's air there, and this is the direction of the light beam. It hits the surface of the water and bends closer to the vertical. So the Greeks understood that if you divide that angle by that smaller angle, you get a number that's constant. And if the light comes in at a much sort of shallower angle, then that's bigger. That will also be bigger, but the ratio is the same. A scholar during the medieval Islamic period said, actually, that's not quite right. The ratio of the angles is actually equivalent to dividing the length of that arc, this line here, the curved one, by the length of that one. That divided by that gives you the same number as dividing that angle by that angle. And he said, no, that's not right. You have to divide this half chord, this straight line, by this line. So if the angles are very, very small, those two lengths are about, the paths are about the same. And those two are the same. So it sort of doesn't matter whether you use the Greek method or this new method. But as the angles get bigger, it becomes more important. That is exactly Snell's law of refraction, because the way we say it now is we say the sine of this angle divided by the sine of this angle is a constant, which is equivalent to dividing the chords. So Snell's law, I mean, I go into this detail simply to say that there are things that we take for granted in modern science, modern maths, that is used everywhere in the world, including in the Islamic world, that may have been discovered by pathfinders many hundreds of years earlier. And some of those pathfinders lived during this golden age. So this chap, Ibn Sahel, in his book on the burning instruments, this diagram was found and analyzed by historians of science not that many years ago, and found that actually it's exactly what he talked about was Snell's law of refraction. Not that anyone's suggesting we rewrite all our textbooks and change Snell's law to Ibn Sahel's law of refraction. That would just be silly. But it's interesting that this is the sort of thing they were doing that Europe then revisits and almost sort of reinvents centuries later. The greatest scholar of this period was, of course, Ibn Sina, Avicenna, who was a Persian superstar. He was the Einstein of his... He was the David Beckham of his era. Everyone wanted a piece of him. At this point, the Islamic Empire was somewhat fragmenting into sultanates and dynasties. And if they were wealthy and rich, they would try and persuade him with patronage to come and work in their courts, to come and teach and lecture and write his books. He's regarded as the greatest scholar of Islam, the greatest philosopher since Aristotle. He was also a great physician and wrote a multi-volume book called The Canon of Medicine, which was all about disease and symptoms. It was about anatomy and surgery and general well-being and health. These volumes became the standard textbooks for anyone who wanted to study medicine anywhere in the world, certainly in Europe, for something like 6 centuries. Any time in the medieval times, up until the Renaissance and the likes of Vesalius, books on anatomy. Until that time, you go to a library in Paris and you would expect to see Avicenna's, the Latin translation of Avicenna's books on medicine. Very, very influential. It's interesting now that universities, when students, you're teaching a course and you recommend a book and you say, yeah, but that's probably out of date now. It's 20 years or 30 years out of date. Well, here's a book that was recommended reading for 6 centuries. There are other scholars that have made contributions. Sometimes their contributions are overinflated and exaggerated. Ibn al-Nafis was an anatomist in Syria. He was the first person to understand, he went further than people like Galen understood, that the heart is partitioned, that blood doesn't go from one side to the other. It's got to go the long way round. So he was coming up with the first rudimentary ideas about pulmonary circulation, many centuries before William Harvey. But I say, exaggerating this, when I was writing my book, I was in the mode of saying, wow, telling my friends, did you know so-and-so discovered this? And one of my friends who are obviously getting a bit peeved, we were going out for dinner and he said, okay, so I've booked a taxi to pick you up at 8 o'clock. Do you know taxis were invented by Ibn al-Taxi, that great Persian polymath? Yeah, well, all right. Because it is very much like, the sitcom Goodness Gracious Me and the elderly Indian who thinks everything's invented by Indians. Indian. Televisions. Indian. So there's that danger that you make it sound as though everything was invented in the Islamic Empire. Of course it wasn't. The last subject I wanted to say something about was astronomy. And of course, all the astronomy carried out in this period was done without the help of telescopes. They didn't start until the beginning of the 17th century with people like Galileo. But they would use all manner of instruments, armillary spheres, and astrolabes to measure and track the motion of the heavenly bodies across the sky. But the one thing that they all had in common was that to an astronomer, they all followed Ptolemy's work, Almagest, in that they believed that the Earth was at the center of the universe, and everything else orbits around the Earth. That was developed by the Greeks, and Ptolemy encapsulated all this in his great work, Almagest, and that was one of the texts that was studied for many centuries by these scholars in Islam. So this is a Latin version of Ptolemy's universe, what's called the geocentric model of the universe. A geocentric, Earth at the center, and there's the Earth, and there's the Moon, Mercury, Venus, and there's the Sun. It sits in an orbit around Venus and Mars. And this model got very, very complicated, very, very sophisticated, because, of course, when they look at the sky and look at a planet like Mars, it doesn't just go across like the Moon or the Sun in a nice arc. If you track it night by night, it sort of doubles back on itself, retrograde motion. And they developed these rather sophisticated models with circles going around circles and so on, just to take into account the fact that actually Mars doesn't go around the Earth. They both orbit the sun. Got very complicated, and then Copernicus, of course, in his book, De Revolutionibus, it's so important, Copernicus' contribution, that we think of it as the birth of modern science, the birth of, the beginning of the scientific revolution. And this is this beautiful picture where he gets it spot on. There's the sun, Sol, and then Mercury, Venus, and there's Terra, Earth, and there's the moon going around the Earth. The only thing that orbits the Earth is, in fact, the moon, quite correctly. Two things to add to this, of course. One is that Copernicus wasn't the first person to come up with a heliocentric model. No, it wasn't an Arab. It was a Greek by the name of Aristarchus. Aristarchus, the Greek, said that, hey guys, it's the Earth that goes around the sun, and the Earth spins, and that's why it looks like it. No one believed him. There was one Babylonian astronomer, Seleucus the Babylonian, who was a big fan of Aristarchus. I mean, he was really championing his cause. I believe you, Aristarchus, if no one else will. But, and throughout history, there were those lone voices who suggested that maybe the Earth goes around the sun, not the other way around. But the standard sort of dogma at the time really slapped them down. It's the sort of lesson that people who think they've come up with a new theory that disproves Einstein, for instance, they take heart in that. They say, oh, so see, no one believed, Aristarchus. No one even believed Einstein. And here's my theory, disproving Einstein's relativity with nothing more than GCSE maths. And they, I want to get this off my chest. They send this stuff to me, and I think, oh, bless, isn't that sweet? Yeah, but Einstein, yes, but he was Einstein. With all due respect, you're not. Anyway, and the other thing to say about Copernicus, of course, Copernicus didn't have the benefit of a telescope to his theory, right? And it was Galileo who came afterwards who proved it. But he used mathematics that was developed by Islamic astronomers several centuries before. And there are all sorts of texts that are now being uncovered where you can make the comparison between Copernicus's work and work, for instance, this is a Persian astronomer by the name of Tusi, who works in an observatory in northwest Iran called Maraga, where, again, an observatory with no telescopes, but, still they had all the other instruments at the time. But they developed the mathematical techniques that Copernicus used. Copernicus was certainly aware of the Latin translations of many of these texts on astronomy from a few centuries earlier. So this was an enlightened period where these scholars were asking questions about the world around them, and it didn't seem to conflict with their religious faith. Now, of course, it was easier back then because let's not beat about the bush. This was the medieval times, and there were a lot of things they got wrong. I'm highlighting the good stuff. There was other stuff that wasn't quite right. But nevertheless, these scholars were people who weren't doing science because they had to, or because they were told to. The new religion of Islam, when it first came about, it did encourage a lot of science. For instance, astronomy really began as distinct from astrology because Muslims wanted to know when to pray and when to fast during Ramadan, so they needed to know the cycle of the moon. They needed to develop what's called spherical geometry, not Euclidean geometry, that's all stuff on flat bits of paper, but spherical geometry, because they wanted to know wherever they were in this vast empire, which direction should they face towards Mecca? How do you work that out? It's actually complicated mathematics. So a lot of these sciences developed in the service of religion. They were also encouraged by religion. Back then, there were all sorts of quotes about seeking knowledge wherever you may find it, even if it has to take you as far as China. That God's given you a brain, go out and learn about His creation, and so on. And in contrast, a lot of Muslims I speak to today who are very devout will say, "Oh, it's all in the Quran. No, the Big Bang is all there. Relativity, quantum mechanics is there." Yeah, please. Even when I was filming, and I was filming in Iran, and we went to the holy city of Isfahan, and I spoke to clerics there. And they were quite adamant that the Quran is a book that tells Muslims how to lead their lives. It's not a book on medicine. It's not a book on astronomy or mathematics. But it's a shame that there was a period 1,000 years ago when scholars were not sort of held back from asking questions about the world around them. And that seems to have gone. Now, you might ask what happened, what went wrong. In a way, it's sort of an unfair question, because people always say, oh, yeah, so what went wrong with the Islamic Empire? It went into decline. No one asked what went wrong with the Golden Age of Athens or Alexandria. Well, some say with Alexandria, I suppose the burning of the Library of Alexandria. But, civilizations rise and fall. There are periods when a civilization is powerful and self-confident and wealthy and providing patronage for scholarship and books and so on. And then there are other periods when they get more concerned with fighting their neighbors or fighting each other, and science takes, a back seat. In the Islamic world, there was a move towards more conservative, orthodox Islam, but it didn't really affect the development of science. It did affect philosophy. So there was a theologian by the name of Al-Ghazali who wrote and criticizing philosophers like Avicenna. In fact, he wrote a book called The Incoherence of the Philosophers, saying that they were too Aristotelian, they weren't Islamic enough in their thinking. But even philosophy didn't stop. Another Islamic philosopher, Ibn Rushd, known in Europe as Averroes, countered Al-Ghazali's work, and he wrote a book called The Incoherence of the Incoherence, which was very well received. So even in philosophy, things didn't die down, but certainly in astronomy and medicine and maths, science carried on in the Islamic world well into the 14th, 15th century. It's just that by then, Europe had reawoken and just meteorically took off, leaving everything else behind it. What about today? What lessons then can we learn from this period? I'll just give you a few facts and figures. There are 57 members, Islamic countries, the organization of the Islamic Conference, in which Islam is the official religion. Among them, there are the very wealthy Gulf states, for instance, but also very, very poor states. So it's very difficult to have a pattern to say, well, how much do they spend GDP on science? How much do they value learning and scholarship? More interestingly, Muslim countries have fewer than 10 scientists, engineers, and technicians per 1,000 population. And see how that compares with 140 in the developed world and 40 average around the world. In the Arab world, and I can say this because I'm half Arab, and it's a shameful statistic as far as I'm concerned. The entire Arab world produced less papers, scientific papers, in 2005 than a single university, Harvard, in the US. And this is many, many hundreds of millions of people. So what is it? Why is the Islamic world disengaged from science? It's true that it does view aspects of science with suspicion. That it's some atheist Western construct that is being imposed on them. However, there are signs that they're moving in the right direction. If we think about how science developed, in the Golden Age of Athens, they were very wealthy and powerful. During the Abbasid period, the Islamic Empire, it was wealth that kick-started the translation movement. In the Renaissance, it was thanks to the money of families like the Medicis that funded so much scholarship. So you need money. So you look to countries like the Gulf and see what they're doing. So there's a start. But how about areas of research, fundamental research in very devout conservative countries like Iran? The Royan Institute, and I went there and filmed there with the BBC a few years ago. So we were filming there and we had all access. And we were actually then, this is 2008, we were going to go and film one of the nuclear reactors there. And we had to go through various ministerial hoops. And at the last hurdle, they said, BBC, did you say? Oh, sorry. No. So we couldn't go there. But the Royan Institute, it carries out cloning research, stem cell research. So I think that's Ayatollah Khamenei visiting them. How good is the science? Well, I'm not a geneticist, and I don't know to what extent the work that they're carrying out there is being published in the leading journals. But as far as I can tell, it's genuine, they're free to do what they want to do. They are overseen by a committee of mullahs who decide whether it's ethically, Islamically appropriate to do the research that they do. But if you think about it, the ethics of genetic research is something that we are concerned about as well. And whether your ethics, how do you do, I'm not a cultural relativist, so I'm not going to make apologies for any ethics based on any ideology or religious belief. But, overseeing what you can and can't do is important in science and should be in place. What's interesting here is that at the Rayan, they have no problem with doing embryonic stem cell research, because Muslims believe that the fertilized egg is only ensouled after many days, I think it's after 40 days, whereas the Catholic Church believes it's a human being straight away from fertilization. So Catholics would have a big problem with stem cell research, but not a country like Iran. So it is going in the right direction. Now, it's very easy for us to say, oh, yes, but look, it's all, as long as it fits in with the religion of Islam, and therefore it's not really free. They're not really free to ask questions. Well, let's compare it with the West. Let's compare it with some of the ideas that we have here, whether it's diluting something 30 times with homeopathy or crystal healing or reflexology. You sort of feel a country like Iran, well, they've got a good excuse. It's a conservative Muslim country that nevertheless wants to sort of advance in science and wants to catch up with the rest of the world, and they're putting money into research. What's our excuse in the 21st century? But is it free? Is it really, are they moving in the right direction? Are they learning the lessons from the past? You see, the golden age of Arabic science, I don't believe is something that the Islamic world should be harking back to and wanting to reclaim. That was 1,000 years ago. That was a long time ago. The world has moved on. If it gives people a sense of pride in their heritage, then that's a good thing. But what is important is why we do science. How are we thinking? How can we think rationally? How can we have open, free questioning? Many parts of the Islamic world haven't got there yet. Many parts of even in the developed world. But certainly they will be putting money into science essentially as a driver for technology, as a driver for the economy. The science is important. Sometimes we see that happening in this country as well, that scientific researchers are always asked to provide, what the impact and application of their research is. And blue sky, curiosity-driven research has to take a back seat. Well, certainly in the Islamic world, a lot of the science that they're doing is in the service of the economy or their defense industry and so on, not necessarily because they're just curious about how the world works. There are examples. There's a new research university in Jeddah in Saudi Arabia called KAUST. It now has the world's third largest endowment as a university in the whole world. It's hugely wealthy, billions of dollars. It was created just in a few years. They bring scholars over from the US, from Harvard and Yale and other big Ivy League universities to teach a course and give them ridiculous amounts of money to teach a course, so they're quite happy to do it. It's the only co-educational institution in Saudi Arabia. It's moving up the league tables, it's doing good quality research, but it's a bubble within a very conservative country. And what it's not doing is changing hearts and minds among the wider population. Similarly, places like Education City in Qatar, the Qatar Foundation is very wealthy, putting a lot of money into science and research. Likewise in the Emirates. Again, it's a bubble, but it's moving in the right direction. You start by putting money into it. It's not enough to have shining universities and new bits of kit if the wider population are disengaged from science. But what we're seeing is the shoots of recovery in some of these countries. A nice example is something called Sesame. It's a research project. It involves it's a bit like a particle accelerator, like the Large Hadron Collider, but it's called a synchrotron source. It accelerates subatomic particles around in a circle, and they give off X-rays. And those X-rays are then used to probe and study other materials. Well, the Sesame project in Jordan now, just like CERN and the Large Hadron Collider has lots of countries, all partners, member states of CERN, Sesame has numbered among its member states Iran and Israel. It's incredible that in science, those sort of political differences are just not relevant. If what they're really driven by is just wanting to understand how the universe works. My final slide is this statue that is, it depicts a medieval scholar who's built himself a set of wings. It's on the main road from the center of Baghdad out to the airport. Now, I remember as a kid, when we were traveling to the airport, or for summer holidays, we'd come over to Britain for summer holidays to visit my maternal grandparents. And that was always, seeing that statue meant we were nearly there, we were nearly at the airport. It's, the scholar's name is Abbas ibn Farnas. He was an Andalusian Arab inventor and engineer, and he is said to have been the first person to fly. He, of a sort. He built himself a set of wings and jumped off the side of a mountain. I'm not quite sure how high. But he was quite elderly when he did this, around about 60 years old. And he hurt his back when landing because he'd failed to build a tail onto these things. So that, he watched birds fly, but he couldn't control his path. But that sort of ingenuity, he wasn't doing that because there was some government project that needed him to do it. He wasn't doing it in the service of technology. He wasn't doing it because he could see he could make a buck out of, some building lots of wings for people so they could get from one place to another more quickly. He was doing it just because he was curious about the world. That sense of curiosity that we had back then in the Golden Age is something that I think the Islamic world still has to rediscover. I'd like to think it's starting the first steps in that direction. Thank you very much.
That was terrific. Thank you very much. Now, I'm sure you've got questions, thoughts, contributions that you'd like to put to Jim.
Yeah, I'm curious that other cultures like the Jains and so on gave us, the number 0, and Jains today, all the ones I know, are quite involved in mathematical sciences, computer sciences, and so on. But is there a particular reason why the Arabic culture has gone the way it has, or is it just do you think it's just a statistical fluke of how civilizations go?
Well, I think it's very. There are complicated reasons. Usually, the simplistic answer is that the Mongol invasion in the mid-13th century, destroyed all the libraries in Baghdad, and that sort of brought things to an end. I don't buy that. There were many cities in the Islamic world that the Mongols didn't reach: Damascus, Cairo, Cordoba, Granada, where there were very many libraries there as well. So I don't think that put a stop to it. And the other argument is that Islam became very much more conservative and orthodox and anti-scientific. But as I mentioned, I think maybe in some areas, like philosophy, that might be true. But there are lots of other subtle reasons. One of the reasons why it flourished as a golden age was because the Islamic Empire learnt from Chinese prisoners of war how to make paper. And paper was much cheaper than parchment or papyrus, and so they could produce many more books. But at the other end, they didn't take up the printing press when they could have done. Venetian printers produced typeset copies of the Quran and tried to sell it to the Ottomans. The Ottomans hated it because there were typographical mistakes. And the last thing you want to do is have a typographical mistake in the Quran. It's blasphemy. And so they were into their calligraphy and they didn't. So that might have been a reason why they were held back. But in general, yes, I think it's fragmentation of the empire. Civilizations rise and fall, and we don't ask what happened to the Greeks after the 1st, 2nd, 3rd century Alexandria.
Do you think one reason why ideas like homeopathy are still taken seriously by people, it's because we don't teach kids in school how to think. We just teach them what are the supposed facts? Or is there any other reason behind it?
Well, I certainly think that is a problem. That increasingly, science is just reciting facts. I mean, and in fact, I did my education in Iraq where it was very much like that. That you memorize stuff, and there's very little in the way of understanding why. Facts you can remember them, or you can, especially these days, just look them up. But understanding how science works is very important. I certainly don't think that is taught. Certainly not in many countries around the world. I think we try to do that here, teaching kids to explore and to think and to experiment, but maybe not enough even here.
But it doesn't protect them from nonsense that comes along of one kind or another.
No. I think if you don't understand the scientific method and evidence, then of course you're going to be open to any crazy idea that comes along, because how, particularly in today where all information is out there and is so readily available, how do you discriminate? How do you, from the 100 blogs about a particular subject, how do you know which is the person who understands, if it's scientific, how it understands a scientific method compared with all the everyone else who just feels they have a voice? Climate change is a good example.
I would like to suggest that one of the obstacles to progress is the denial of the role of women and the participation of women in the Islamic world, particularly when you were talking just now about stem cell research and genetics. How can you pursue that if Islam teaches that the mother makes no biological contribution to the baby in her womb? She's just an incubator.
Yeah, well, I just call that ignorance. I don't refer to that as religious teaching. That's just ignorance. People don't understand. I mean, there are all sorts of even shameful history in the West of women who've been overlooked for their contribution. There's a whole list of women who should have won Nobel Prizes who didn't because they were women. But yeah, those ideas that are not founded, whether it's to do with the role of women or anything, ideas that are not founded on science, that are just based on superstition or ideas handed down through culture that are not scientific, do stand in the way of progress. It's very hard to change people's attitudes. You can even sometimes present them with the evidence and they won't accept it because a way of thinking is so ingrained as part of the culture, and that always takes time.
Let me ask you, how do you explain then the people who are religious and scientific, who have two totally different sets of thoughts and ways of thinking that run side by side, a sort of bifurcation of the brain? How do you account for that?
I think in many areas of science, they have to leave their religious brain outside the lab. Otherwise, there's a conflict. I think it depends on the area of science. I mean, if you're an evolutionary biologist, but your religion tells you that the creationism is true, then you're in the wrong business. You're in the wrong science. Sorry, but if you're a laser physicist or an engineer or somewhere where whatever genuinely held religious faith that you have doesn't butt up or conflict against your science.
It's a method of thinking.
Well, but there are very good scientists who are also religious. I mean, one of the people, for instance, one of the women who missed out on Nobel Prize was Jocelyn Bell Burnell, who's an astrophysicist. She's also a Quaker. Now, I know Quakerism is quite benign compared with fundamentalist Christians or Muslims or anything, but nevertheless, I would never think that someone like Jocelyn Bell Burnell doesn't think scientifically or doesn't think in the right way. She is a brilliant astrophysicist, and that I haven't probed with her to what extent that might butt up against her faith, and how can you believe in the rational idea of evidence and science and cause and effect, but in the other parts of your brain you believe in some supernatural, divine creator? But people do, and I don't see that the quality of their science being any lower.
two short questions. One is, how did the Arab numbers come into Europe? 1, 2, 3, the digits. And the other one is, what was the relation between the Andalusian scientists, Arab of Jewish, and the Abbasid that you were mostly talking about?
Okay, the first question, well, of course, Arab numerals are really Hindu numerals because they came from India. They came via the Islamic world, and it was the decimal system 1 to 9 plus the 0. 0 as a symbol was used by the Mayans and the Babylonians. 0 as a concept was discussed by the Greeks like Aristotle, but 0 as a number came in that package with 1 to 9 from India, developed by mathematicians there in the 4th, 5th, 6th century. It passed through the Islamic world. They were very slow to take it up in the Islamic world as well, and even slower in Europe. But people like Fibonacci took it through to Europe. In 10th, 11th, 12th century, it slowly moved across. We now refer to it as Hindu-Arabic numerals, but I don't think it's the Arabic in the name isn't just because they sort of passed it on, because the Arabs did give us the decimal point, which is part of the decimal system, which is very important. So we have to credit them somewhere. Your second question, well, yes, the Andalusian part of the Islamic world were not part of the Abbasid dynasty. They were part of the older Umayyad dynasty that ruled in Damascus. And when the Abbasids came to power, those who could among the Umayyads just ran. They escaped across North Africa and settled up in Spain, Andalusia. And for a century or more, there was this rivalry between the Andalusians and the Abbasids of Baghdad. In fact, the Andalusians were quite jealous of the Abbasids in Baghdad. Or, the latest fashions in clothing and food and music, they'd find out what the Abbasids into at the moment, and then they would copy them somewhat later. So it's quite amusing to see the scholars and how they interacted with the, from one end to the other of this huge empire.
Thank you, Jim, for a wonderful talk. I'm an engineer, and of course the British media, including Polly's paper, which I read every day, doesn't seem to understand the difference between science and engineering. Engineering being, of course, at the more at the creative end for the production of wealth, as we know. And for example, the Large Hadron Collider, which you have referred to, is a huge engineering achievement which enabled the intellectual genius of Peter Higgs to come to the fore. Yeah. Right. Now we move on to the real question. What is really the status of engineering now in the Arab world, in Iran and so on? After all, they are producing technologies or using technologies, or is it all imported for the suspected nuclear weapon development? What is the status of engineering as distinct from science?
Well, certainly a lot of scientists and engineers from that part of the world come to the West to study, and they get their PhDs and they go back there. It's an accelerated process. I think to a large extent, those who are put in charge of big projects in that part of the world don't have the experience that their counterparts in the developed world would have. So there you see sort of quite young people in charge of large, important engineering projects. But on the whole, I think they're moving very quickly, and they are making use of. They do still, maybe not Iran, but certainly the Gulf states make use of engineering expertise from the West to help them. But yes, there is a distinction between science and engineering. I was talking about, curiosity-driven research, doing just, for the sake of it. My son is in his 4th year of an electronic engineering degree, and I didn't want to push him into doing physics. I thought I'd let him choose. And then when he said no, he wanted to do engineering, his rationale was, he said, "Dad, you can do the deep thinking. I want to do something useful." And that was his definition, the dividing line between. I mean, I know engineers do deep thinking, and sometimes physicists can be useful, but that was a nice dividing line.
Yeah.
How advanced was surgery in the Arab Golden Period? Did they have anaesthetics? Is that something else that was forgotten?
Yes, that surgery was actually very advanced. One of the great names that I didn't mention. Sorry, where was the questioner? Can you? Oh yeah, hello. One of the characters I didn't mention was another Andalusian by the name of Al-Zahrawi. And Al-Zahrawi is credited with actually inventing lots of surgical instruments, forceps and the syringe, using catgut for surgery, even rudimentary anesthesia. And there are books that were then translated into Latin, and some of these instruments were then sort of developed in Europe that contain, hundreds of surgical instruments that all seem to have been down to this one person. So he sort of stands out as a great medieval surgeon that we have to thank for all sorts of instruments that we still use today. There weren't that many that I'm aware of other than Al-Zahrawi. Avicenna Ibn Sina certainly wrote about surgery, but it was rather more sort of theoretical than practical.
I've just got a suggestion and see what you think about it. How about scientists operationalise the concept of God? And you call it a singularity, don't you, that presumably started the universe. Why don't scientists refer to that as God and define God as the singularity, and then everybody in the world can believe in God and we can all get on?
Scientists got into a lot of trouble calling the Higgs boson the God particle. There's an American author, Leon Lederman, so wishes his publishers hadn't convinced him to use that in the title of his book. Well, one reason why that's not a good idea is because the singularity may not be the first event. Maybe our universe was as a bubble that was formed within a higher dimensional multiverse, and lots of universes are created. The trouble with saying, call that initial event God, is that you then stop asking. That's what science doesn't do. Science doesn't want to stop asking why. As soon as you say, oh, because God said so, or because it was God, then you sit back and you don't need an explanation. And that goes against a scientist's belief.
Again, thanks. Were there any Arab scholars that got anywhere close to evolution?
Funny you should say that. There was a scholar who actually he earned his living teaching the caliph's children. His nickname was Al-Jahaz, which means the boggle-eyed. And apparently he was a very scary-looking person, so I don't know how, the kids, they must have absolutely terrified them. But he wrote a book called The Book of Animals. Now, Aristotle, I think, wrote the book of Animals, but he also wrote this book. So this was about in the 9th century. And before I did my research, I'd heard some people who were trying to big up Arabic science, probably more than it deserved, were saying, oh yes, Al-Jahaz came up with evolution theory long before Darwin. And so I went and I found his Book of Animals in Arabic, the original Arabic, in the British Library, and I found the passages. And he talks about dogs and foxes and wolves being very similar, and maybe they had a common ancestor, which is interesting. He also says, he talks about the people in the Maghreb, in Morocco, being strange looking, and that's to do because they breathe bad air there or something, and that's why they look the way they do. So there's a lot of nonsense. But he was certainly thinking about the fact that species change and species can be related to each other, as opposed to a God creating everything as it is and not changing. So yeah, the rudimentary. I wouldn't quite call it natural selection, but give him his due. It was the 9th century.
Thank you. My father was a physicist, and he always impressed upon me the great contribution of the Arab and Islamic world to science and mathematics, and it was wonderful to hear you talking about it today and in expanding my knowledge of all of this. But my question is about today. A parallel religion, if one likes, I think is conservative Catholicism, and we have a large Irish community in Britain, and I remember 40, 50 years ago, a very, very conservative Catholicism, which seems to have largely dissolved, and many people of Irish extraction now are liberal. They've been tainted by the godless English. I'm a godless English person myself, I have to say. But do you think this liberalisation, it's been fairly rapid, in fact, could that happen to Muslims who live in Britain as well, do you think, over time?
I'd like to think so, but of course what we see is a trend going in the opposite direction. My father gets very frustrated by his relatives, younger women, who will cover up when he walks into the room. I mean, he's 83. He says, "What do you think I'm going to do? I'm 83. You don't need to cover up." And women of his generation, they say, "We fought for the right not to wear the hijab, and now our daughters are wearing it." Yes, you do wonder whether things are moving in the wrong direction. But then just look at atheism and humanism and the secularization sweeping across Britain today. It's happening far quicker than anyone could have thought. Every census, and there's the higher percentage of people who say we are not religious. We don't need a religious faith. So yeah, I think things could happen. I'm not going to say religion is going to become extinct and die out within my lifetime. Of course it's not. And, to be fair, for a lot of people, religion is important. Not everything about religion is bad, right? There's good architecture, good music, good, the sense of community, sense of social cohesion. It provides hope. There might be some nonsense about some, magic man up in the clouds, but there are reasons why religion is a good thing. So I don't think it's going to disappear, but a sort of a liberalisation, if all religion was just Church of England, then no one would have a problem. Well, okay, there are things we have to do, and as president of the British Humanist Association, I say we have many campaigns that are active at the moment to bring about a fairer society in
Wait till you next come across the massive bishops in the Lord.
For instance,
things like
yes,
right
okay.
to die.
Yes, okay. Good point.
There was one last one. We have time for one last one.
Well, this is really linking that last point about liberalisation with the earlier, larger question about the relationship between religion and science. Because, despite what many of us might think about the incompatibility between religion and scientific inquiry, plenty of the scientists that you talked about earlier in this country who are Christians would see no problem there. They'd say the Bible is not a book of science and creationists just don't know how to read the Bible. Right. And what we're doing is exploring the wonders of God's creation, and there's absolutely no problem. So what I wanted to ask is, the scholars that you talked about in the Golden Age of Science, how did they see the authority of the Quran and its relationship to scientific inquiry? I think you alluded to this a little bit, but was there a more liberal attitude towards the reading of the Quran there, and has that been in retreat, and can it be recaptured?
That's very true. There was a movement certainly during the peak of the Golden Age. The sect, Islamic sect that was in the ascendancy was called the Mu'tazilite movement, and they were pretty pragmatic. And it was very much along these lines but of course the interpretation of the Quran was then still in a sense evolving, and so they were freer. Things weren't sort of written down that you can do this or you can't do that, and that should be interpreted in that way. So they're freer to interpret it the way they liked. But it was very much, God's given us brains to go out and explore His wonder and come back and with that new knowledge better interpret His words. And I know of many Muslims today who have that same opinion, very much like people progressives within the Christian church who don't have an issue with it. So I don't see any reason why it can't. I don't think I don't think Islam is special in. It's not. I don't agree. I know a lot of people do, but I don't agree it's endemic to Islam. That Islam is somehow, as apart from other world religions, infected with this way that's an incompatible view. It so happens that we're living in a time when there are a minority of Muslims who have wacky ideas. But I don't see any reason why they should persist or expand in numbers. Well, I hope not.
Jim, thank you so much. That was absolutely